In July 2015, NASA's New Horizons spacecraft made history when it became the first mission to reach Pluto, the most distant dwarf planet ever explored. Before New Horizons, we had very limited detail of Pluto's surface. This image from the Hubble Space Telescope in 2002 was the best we had, a blurry ball with some bright and dark spots. But everything changed in 2015. As the spacecraft flew past Pluto, it captured incredible close-ups that gave us our first real look at the surface. And with them came some big surprises. The flyby sent back stunning high-resolution images for the first time. Pluto wasn't just a blurry dot in the distance, it was a real complex world, and the more scientists looked, the more surprises they found. What did they find? You are watching Kyanite. Pluto is a small but visually stunning world, much smaller than Earth's moon. It's located in the Kuiper belt, a distant region beyond Neptune filled with icy asteroid-like bodies. If we compare Pluto to the 8 planets in our solar system, Pluto was the last one to be explored, mainly because of its incredible distance from Earth. But luckily, the New Horizons team pushed hard for the mission to be approved, and in 2006, it launched under NASA's New Frontiers program, aimed at medium-cost space exploration. The goal was to reach Pluto as fast as possible. A lightweight probe on the most powerful rocket available at the time, a fully boosted Atlas V. On July 14, 2015, New Horizons made its closest approach, passing just 12,500 kilometers above Pluto's surface. But the images didn't come back immediately. During the flyby, the probe was too busy taking photos and measurements to transmit anything. Then, once it started sending data, the uplink was really slow, just 1 kilobit per second, and it took 4.5 hours for each signal to reach Earth. But what came back was worth the wait. Stunning mountain ranges, icy plains, glaciers, and even signs of an atmosphere. Among the most intriguing is what appears to be an ancient lake frozen in time. Located near the mountains west of Pluto's famous heart-shaped area, this lake spans about 20 miles across. While today it appears frozen, solid, evidence suggests that it may have once held liquid, likely liquid nitrogen. This is remarkable considering surface temperatures on Pluto hover around -382 degrees Fahrenheit. Researchers believe Pluto's distance from the Sun causes dramatic temperature swings throughout its long 248-year orbit. These shifts may be enough to briefly allow nitrogen to exist in a liquid state, just long enough to carve out river channels and pour into lakes like this one, before freezing once more. Another fascinating discovery was Pluto's thin but complex atmosphere. This hazy layer is made primarily of nitrogen, with traces of methane and other gases. And it's incredibly faint, over 80,000 times thinner than Earth's. Sunlight interacting with methane in the atmosphere creates tiny particles of hydrocarbons that scatter blue light, which is why Pluto's haze appears bluish in some images. These haze particles gradually settle, forming dozens of thin, layered bands that stretch more than 120 miles above the surface. As Pluto moves farther from the Sun, scientists believe the atmosphere begins to freeze, falling back to the surface like snow. Whether it falls in flakes or icy grains is still unknown. But in areas like the heart-shaped Tombaugh region, we may already be seeing these layers of nitrogen snow blanketing the terrain. Near this area lies Sputnik Planitia, a massive plain about the size of Texas made mostly of nitrogen ice. It's remarkably flat and covered with large polygon-shaped cells. These polygons are likely caused by convection, the slow movement of warmer ice rising and cooler ice sinking driven by heat from Pluto's interior. The lack of craters in this area suggests that it's geologically young, maybe only about 10 million years old. Pluto isn't just flat plains and icy fields. It also features towering mountains that rival some of the tallest ranges on Earth. Located in Pluto's southern hemisphere, these peaks may look like snow-covered mountains, but they're anything but normal. Instead of rock, they're made of solid water ice, as hard as granite under Pluto's frigid conditions and topped with methane ice. Some of these mountains rise over 2.2 miles high. Yet unlike Earth's mountains, which formed from tectonic activity or volcanic uplift, Pluto's peaks likely formed through a unique process called sublimation erosion. This happens when ice on the surface turns directly into gas, slowly reshaping the landscape over time and leaving behind sharp shapes in the landscape. While Pluto isn't geologically active in the way Earth is, some regions show strong signs of resurfacing, including what appears to be giant ice volcanoes. These cryovolcanoes don't erupt molten rock. Instead, they release slushy mixtures of water, ammonia, and methane. We've seen similar features on icy moons like Europa and Enceladus. But Pluto may host the largest one discovered so far. A top candidate is Right Mons, a huge mountain with a wide sunken peak that rises about 2.5 miles above the surrounding land. If confirmed, Right Mons could be one of the biggest cryovolcanoes ever found in our solar system. On the western edge of Pluto's heart-shaped plain, scientists discovered something even more unexpected. These features look remarkably similar to sand dunes on Earth and seem to be formed by wind-blowing particles across the surface. But because Pluto's atmosphere is so thin, wind alone probably isn't enough. Instead, researchers think that nitrogen ice may sublimate, releasing gas that lifts tiny methane ice particles off the ground. Once airborne, these grains can be carried by Pluto's weak winds and form dune-like structures. Some of Pluto's dunes are massive, stretching for miles, reaching heights as tall as mountains. Pluto's low gravity makes it easier for particles to travel long distances, helping shape these deserts. Additionally, one of Pluto's most bizarre features lies right in the center of its heart, large blocks of water ice that appear to float across the surface. These chunks range from 1 to several miles wide and drift across a frozen plain of nitrogen ice. Because water ice is less dense than nitrogen ice, these blocks behave like icebergs, floating in a frozen sea. But what moves them? The answer may be convection. Beneath the surface, warmer nitrogen ice slowly rises and falls in a pattern similar to boiling water over millions of years. This slow movement may carry the floating ice blocks toward the edges of large cell-like shapes on Pluto's surface. Another interesting area is Belton Regio, a dark reddish region that's much older and has more craters than Sputnik Planitia. The reddish color is caused by tholins, complex hydrocarbons formed when sunlight interacts with gases like methane. These tholins are found not only on Pluto, but on some of Saturn's moons as well. Interestingly, this is even related to the reddish appearance of the North Pole of Pluto's largest moon, Charon. Since Pluto's gravity is weak, some of the tholins released during eruptions escape into space and travel the 12,200 miles to Charon, settling on its pole. Due to the tidal lock between the two bodies, this suggests that even in the outer solar system, Pluto is not just frozen and dead, and what lies beneath Pluto's surface may be even more incredible. In 2020, scientists suggested that Pluto might have a subsurface liquid ocean, much like the icy moons of Jupiter and Saturn. At first, Pluto was thought to have formed cold, but evidence of surface expansion, like giant cracks, suggests it may have formed hot, possibly due to collisions in the early solar system. That heat could have melted internal ice into a long-lasting ocean. If that's true, then Pluto and potentially many other Kuiper Belt objects may be more habitable than we ever imagined. A new mission concept was even submitted to NASA, aiming to take a closer look at Pluto and its surrounding system, proposed in late 2020. The Persephone mission would explore whether Pluto has an ocean and how its surface and atmosphere have changed over time. Persephone would send a spacecraft equipped with high-resolution cameras to orbit Pluto for 3 years, mapping the planet and its largest moon. However, some scientists believe that going back to Pluto isn't worth the cost, or the 30-year journey it would take to get there. To become an official NASA mission, Persephone will need to convince the broader scientific community that the questions it could answer are worth the effort. Instead of Pluto, upcoming missions are expected to focus on other parts of the solar system, like the moons of Saturn and Jupiter, many of which are already known to harbor oceans beneath their icy crusts. It would cost less to reach than Pluto. For now, the images captured by New Horizons will probably be the best pictures of Pluto we'll have for a long time. Pluto can still be observed from afar by telescopes like the James Webb, but the view doesn't come close to what New Horizons revealed. That's because James Webb was designed for different types of observations, mainly in infrared light. At least one thing is certain: New Horizons showed us that Pluto is much more than just a frozen body at the edge of the solar system. Maybe one day a spacecraft will come back to explore Pluto again. Besides this video you just watched, there are many others on the channel waiting to be seen. To get more videos like this, subscribe to the channel. See you next time.